Hi, I'm Stevie C and the place to be. In this video, I'm going to be taking a look inside one of these cheap LED floodlights available from eBay and hopefully modifying it to contain my custom Jojoba Bunny PCB. So this is a 20-watt model. It cost £5, yes, 500 pence, arrived several days after ordering and reasonably well packed. There's the usual tiny wee flex pre-attached, so you'd need an IP-rated junction box to install this as is. But I'll be using my own flex, so it matters not. So just out of curiosity, we have earth continuity. So upon opening the light, I can see that the earth wire is properly bonded onto the chassis, and it's not just flapping about in the breeze, as is sometimes the case. We see there's a waterproof gland in there, and a little silicon type seal, which will hopefully keep the water out, and there's a tiny little power supply that's gooped in. So obviously, because the Jojoba PCB has the power supply built in, I don't need any driver in the back. So I'm just going to pass the mains straight through into the front of the unit where the PCB is. But obviously I'll keep the earth bond on because it's a mains voltage appliance. And this side again, we have the same silicon type seal to keep the water out. We've got a thin foil reflector held in with 4 screws. So before I go ahead and tear it all to bits, I want to see if I've got the full 20-watt light output that I've paid for. Oh, that's bright. So yeah, about 16.5 watts. Bear in mind about 0.6 of those watts is the neon in the quick test. They really didn't want me getting that off in a hurry. I have rather made a mess of it, but this is only a prototype, so next time I think I'll leave the power supply in there without being used. So I'm not sure if you'll see that, but it does say it's a 20-watt driver. So you might recall that the last time I assembled one of these Jojoba PCBs, I realised I made the schoolboy error when I designed it. I didn't check the pad sizes and the drill hole sizes that the software threw down, which means that my components don't quite fit. I'm having to put quite a lot of pressure on that to fit it through the holes. Likewise with the LEDs. They will fit, but they'll sit quite proud of the PCB. So I'm going to have to re-drill these holes. So for that, I'll need my Dremel, and I'll need a selection of tungsten carbide drill bits. So to give you a quick recap of the circuitry, we have two sets of LEDs, 45 for the rear of the bunny and 68 for the front of the bunny. The 45 set will be driven with a 100 nanofarad dropper capacitor and the 68 with a 220 nanofarad dropper capacitor. Each dropper capacitor will have a 1 megohm discharge resistor across it. This will quickly remove any residual charge to prevent you getting a tingle from the pins after unplugging it. I've also made provision for a 100 to 330 ohm inrush limit resistor. This will also act as a fuse should the worst come to the worst. We then have a full wave bridge rectifier to convert AC to DC and an electrolytic capacitor to remove flicker. I've worked it out so that the set of 45 LEDs, we assume a forward voltage of 3.5 volts. On the full wave rectified and smooth DC supply, 182 volts will be dropped across the capacitor. 100 nanofarad is approximately equal to 31,831 ohms, which means that the back of the bunny should run about 5.7 milliamps. Likewise, with the front of the bunny, we have 68 LEDs. Again, we assume a forward voltage of 3.5 volts. And powered by the full wave rectified and smooth supply, we have 102 volts to drop across the capacitor. The 220 nanofarad capacitor is roughly equivalent to 14,468 ohms, so about 7 milliamps. So I'm going to start by soldering the resistors in first because they're flat, then I'll move on to the LEDs and then finally the rest of the power supply components. So let's cue the music. So what you probably saw me doing there was testing the continuity of the LEDs by powering it up without the main dropper capacitor and just relying on the small amount of current trickled through by the 1 megohm resistor. But as sod's law would have it, once I assembled it into the frame, this stopped working. So you probably also saw me doing a little bit of fault finding, and it was just a dry solder joint. You probably also saw me using some packaging material to separate the electrical connections from the metal chassis. In a final product, I'd probably use PCB pillars. So now it's time to plug it in and see what kind of power it draws. So yeah, about 1.6, 1.7 watts. Obviously that'll vary up and down depending on what colours the LEDs are doing. Oh, we've got some dead LEDs in there. Oh, down by his feet. Okay, take two. So there you have it, a prototype of my IP-rated Jojoba Bunny PCB. I would say it's ready for installation into somebody's garden now, except for the fact that I've destroyed the rear case trying to get the old power supply out. But again, this is just a prototype. Notes for next time. I would either use a solvent to remove the old LED driver, or just leave it in there, not connected. I would probably use PCB pillars to raise the board up from the metal chassis instead of using plastic packaging. But it's a prototype, it worked eventually, it didn't go kablamo, and I have a project that I'm happy with. So if you liked this video, please click like. If you aren't already subscribed, please click subscribe because it really helps the channel. If you have any suggestions for future videos or comments about this one, leave a comment. And until next time, thanks for watching.